Hello guys, welcome to Sneeze Sky. So in today's episode we are going to solve the LeetCode problem 1390, that is for devices. So this is a medium level problem and it's actually today's problem of the day. So we will learn about the topics that were used in this problem at the end, because I don't want to hinder your intuition, because you might be having your own ways to solve this problem, right? So we will first understand the problem and then dive into the solution. So it's a very simple problem even if it is marked as medium. So I'll just help you with the question. Given an integer array nums, return the sum of devices of the integer in that array that have exactly 4 devices. If there is no such integer in that array, return 0. So the question is pretty straightforward. There is nothing hidden or nothing complicated in this question. So there are a few examples given, like nums 21, 4, 7, and the output is 32. So we will first start by understanding the example. So the first example says that we are given a nums array with 21, 4 and 7 in it. So our aim is to find which all numbers is divisible for 21. It's the devices of 21. How many devices are there? So what is a divisor? If 21 modulo 1, it's 0. 21 modulo 3 is 0. 21 modulo 7 is 0. 21 modulo 21 is 0. So whichever values 21 is divisible by. So divisible by 21 is divisible by 1. 21 is divisible by 3, 21 is divisible by 7, 21 is divisible by 21. So whichever values it is divisible by, these are the devices. Okay, so we are going in a layman term. So if you find it too simple, you could just skip ahead a few seconds, so you'll be able to get into the more detailed answer. Okay, so these are the devices. So we are having these values. So as you could see that we are getting the devices of each and every number, whether it is 21, whether it is 4 or whether it is 7, we are getting the devices. And here you could see that for 21 there are 4 devices. So our question says that which of them are having exactly 4 devices. So 21 is the one which is having exactly 4 devices, and what we are doing, we are adding this 1 plus 3 plus 7 plus 21. So that value is 32. Okay, so that's how we got the value 34. 21 plus 7 plus 3 plus 1 equal to 32. So now you know how we got 64 here, right? If there are more than one element that is having 4 devices, in that case we will be adding it. Okay, so the for first value, that is 21, we are having the 64 as the sum of devices. For the second 21, for first divisor 21, we are having sum as 32. The second divisor, we are having the divisor sum as 32. Then 32 plus 32 is 64. So that's how we got the output as 64. So now the question is very clear. So you could pause this video for a few minutes and think of a solution. If you're not able to understand or solve it, you could resume this video. I hope you have came up with some approach. If not, we can solve it together. So I'm going to use a approach that is called square root limit. So few of the layman terms or thought process that you might had in your mind, some of you might be thinking, at least few of them might have thought this, like I'll be running a loop from 1 to n. Okay, and once I get these values, then I'll do divide, right? So I'll be running a for loop, like if my n is, let's say 4. So in that case, if my value is if my value is n is equal to 4, then I'll be doing 4 by 1. Yeah, I'll get value for 4 by 1, right? So like 4 modulo 1, 4 modulo 2, 4 modulo 3, 4 modulo 4. So 0, 1, 0, 0. So I know that for 4 the divisors are 1, 2 and 4, right? So my question is like why you have to run the entire loop till n? Like let's say n is 1000, so then you have to run this for loop till 1000. If this n is 20,000, in that case this loop has to run 20,000. So as n increase, you have to run that many times. So for that we are using this approach. It's called square root limit. So according to square root limit, you will be only running the loop from 1 to root n. So this much times only we have to run. To find all factors of n, you need to check the numbers up to root n only. Why? Because the divisor is always greater than root n. Okay, so we will understand it better. So let's say our n is 36. Okay, so when so let's say I'm running a for loop. Okay, so my for loop will be running from I till n, right? So I is initially 1 and 1 till 36 it will be running. Okay, my for loop will be running from 1 to 36. So initially it is 1, so then 36 by 1 I'll be checking. Yes, 36 is divisible by 1. So in that case, yes, this is approved. And I'm checking, is 2 divisible? I'm checking if 2 is divisible. 36 by 2. Again I'm getting 18. Okay. And yes, it is also divisible. Then 3. Yes, it's divisible. 4. Yes, it's divisible. 5 is not divisible. 36 by 5 is not equal to a integer. It's some floating point value. So that is not divisible. So similarly, we are checking all these values. And after the middle point, what we observed? We observed that, see, it is repeating. As you can see, right? These and these both are similar, right? Both are similar. Similarly, these and these both are same, right? Then why are we doing it again and again? We only need to do once, right? This running the loop, like only till 1 to root n we need to run the loop. We do not need to run till 1 to n. This is not needed. Okay, so if you are running this for a bigger loop, it can cause a time limit exemption. So in that case, we only need to run till here. So if this was one of the problem that you faced, you could pause this video, think of a solution, and still if you're not able to find the solution, I'll be showing you how to solve it. Okay, so we will now solve this problem. So I'm using Python to solve this problem. You could use your own favorite programming language, translate it to that, and try to solve it once you get the intuition correct. Okay, so here I have written the code blocks into, I had divided into 3. This is my constructor. This is first one is my constructor, and this is the main function which we have given in our question, and this is the other function which I have brought in order to find the factors and the count of factors. So initially I'm having count as 0, factors as 0. So here I'm taking the count because I need to check whichever is having the count as 4. So I'm also taking note of the factor sum. So I'll be adding this factor sum to my final sum. So final sum, I have created a constructor here, so I'll be adding those values to this constructor final sum, this variable. So for whichever values the count is 0, the factors count is 0, I'll be adding it to the factor sum. So here in this while loop, we are running this while loop from I square less than or equal to n. Okay, so this is same as I less than or equal to root n. So we do not need to run the entire loop. As you know, I'll take this example of 36. Okay, so for 36, first one is I square is less than or equal to n, right? So that is 1 less than or equal to 36, 4 less than or equal to 36, 9 less than or equal to 36, 16 less than or equal to 36, 25 less than or equal to 36, 36 less than or equal to 36. So only these many times. After that it's 49. 49 is not less than or equal to 36. So it's only running 6 times. Ideally, if we are running a loop from 1 to n, then it should have run from 1 to 36. So 36 times we have to run that. But since we are using this process, that is square root limit, we are saving time. The time is reduced. Okay, so after doing that check, what we are doing? After doing that check, we are checking the different condition. We are checking if it is divisible. That's the same thing which we are doing here. And if it is divisible, then what we are checking? We are checking if is it the last one that is divisible. So we are here we are checking the case like 6 into 6 equal to 36. If that condition is criteria satisfied, then in that case we only need to add, only one value should be added to the factor sum. Okay, that's why the count is 1. Okay, the factor sum also only one value. If it is in this case, if I is 6 and n was 36, in this case the factor sum plus, we only need to add one value, that is 6. Okay, so that's a condition that's handled here. And here the normal case, like let's say if n was 21, then 7 into 3 is equal to 21. So those cases like 3 and 7, so all those values will be added here in factor sum. Okay, so and all these values will be added and finally be stored in factor sum, and then we will be returning this value. So this will solve this problem. It's a very simple and straightforward problem once you understand this process. Okay, so in the start of this session, I was telling you we will look into the topics that is used to solve this problem at the end, because it will hinder your intuition. If you look at the topic, then we'll be more focused on getting our solution done using that particular topic itself. So we'll be more flexible if we don't jump into the topic first and then solve the problem. So now that we have, because also in the interviews we may not be getting the topics which this question is from, so we have to build that intuition. Okay, so we'll see the topic. So the topic that is used in this problem is array and math. It's the same thing which we used. So in some problems like this one, 4 devices, so such problems, it is always helpful that we know few of the math concept handy, like for example the square root limit. So in order to find a divisor, we do not need to iterate the complete array. So these things you have to keep in mind. So sometimes if such problems come, you could use this approach and it should be handy. Okay, so I hope today's session was helpful. So in future we will be solving more problems. So subscribe to this channel and also like if you like my approach. So thank you so much. We'll meet again. Till then, bye bye.